Today is Monday, July 14th, 2025, and this is Spring Office Hours, Season 4, Episode 19, Spring and Redis with Raphael De Lio. Hope I said that right, Raphael. My name is Dan Vega, Spring Developer Advocate at Broadcom, joined by my good friend and colleague, DaShaun Carter. DaShaun, how's it going?
My name is DaShaun Carter. I'm a Spring Developer Advocate. I still love my job, and I'm jazzed to be here. This is one that I've been excited for. I've been looking forward to this. But today, I'm feeling pretty good. My energy's up. Things are happening. Our ecosystem is amazing, and yeah, it's always a great time to be a Spring developer.
Always a great time. Man, it's middle of July, which means we are about 6 weeks out of a pretty big conference called Spring One. I wanted to make sure I mentioned that today. So if you have not registered for Spring One yet, please head over to spring1.io and register now. We have a lot of really great things planned for that. I know, DaShaun, you are on stage for the keynote. You're in a bunch of sessions. I have a bunch of sessions. We're going to be doing things with some different groups. Oh my God, it's going to be so much fun.
I spent some time this weekend looking at the content for Spring
Yeah.
One, and there are so many things that I am just super excited. There's a bunch of talks that I've never seen before. There's a bunch of new things that I want to learn, and yeah, the content for the Spring One track is really exciting. I am super excited, and I'm very excited to actually be a part of it, but also to be like in the audience for a bunch of these
Yeah,
things. That's
for
going to be
sure.
amazing. It's going to be solid. I'm excited.
What I think what I'm really excited about is that this year we have Spring One, like the different breakout sessions are basically sprinkled throughout VMware Explore. It's no longer just like a single day or a single place. We are going to have breakout sessions. We're going to have meet the experts. Like everything we do at kind of Spring One is going to be sprinkled throughout the whole VMware Explorer show. So I'm excited about that. And if for whatever reason maybe you're not interested in some of the VMware Explorer tracks, you can get a Spring One only ticket. So if you just want to come see all the Spring sessions, meet the Spring team, that kind of thing, I want to make sure that we let you know that you can do that.
So let me just make sure I heard you right. If I only care about Spring, I can go and I can get a ticket that's just for the Spring One track, just for the
Mhm.
Spring sessions and the Spring breakouts. So I don't have to pay the same price as somebody that's going there for Explore.
All of the 10,000 people that go there for like all of the Explorer tracks. Because I get it. Like there's a lot of great value in that, but if you're not there for those sessions, you don't want to pay for it, you can just come hang out with us. So
I like that you mentioned that last part of being able to hang out with us. So anybody that's listening or your friends, your friends are going, if you're going to be at Spring One, we are, there's nothing on the agenda, but we are going to be there and we are going to look for you to hang out with us. One of the things is because we're sprinkled and we're kind of sitting next to this other conference, we're going to have a lot of time to fill in that talk track, the hallway track. So
mhm.
what we're going to say, what I'm going to ask you now is if you're going to be at Spring One, make sure to reach out because we are going to have time. We are going to have time to hang out, and we definitely want to see you there. And now I'll say
And
this last thing: don't meet me there, beat me there. It's in
yeah.
Las Vegas. It's going to be a good time. So yeah, if you're going, let us know because we'd love to hang out.
And we haven't really put a plan together yet, but I'm wondering if we could maybe do another live Spring
Hey,
Office
I
Hours.
always enjoy our live streams from
I
conferences.
do too. And we have all the gear we need now. No more like mics that pick up everything. We got some like
Lavaliers.
nice wireless mics.
Yeah,
Yeah, so it should be a little bit better.
it's
All
going to
right.
be a good time.
So let's get to this. Let me just kind of remind everyone, this is a live stream. We usually stream every Monday, 1 to 2 Eastern. You can catch us on the Spring Developer YouTube channel. If you happen to miss it, you can catch the replay over there. We also take this and turn this into a podcast, so you can get this wherever you get your podcast.
I'm going to say this,
DaShaun,
Dan. I did
for
get
folks that are
another.
here,
Yeah. First, I'm going to say I was in the UK last week and I got specific requests for us
ooh,
to move the show earlier or have another show that's on earlier for our friends over in EMEA. Because right now, for our guests,
yes,
it's 7 o'clock. And we have we have a lot of fans. People like the show. They like our
Well, I
podcast,
mean,
and they want to be able to join in live. So I'm just throwing it out there. Just
I
throwing it out there. I was
in a
asked. I said I would ask.
a glass of wine, listening to DaShaun and Dan.
Ooh.
What's wrong
I
with
mean,
that?
there's nothing wrong with that, except sometimes people are doing their commute. They're on the train and they can't get the
That's
full
true.
experience, right? No glass of wine on your
And
train on the
actually,
way home.
I got to bring that back because we were just in Spain again for spring. And man, people in Europe do not eat dinner around 7 o'clock. I forgot about that. Usually everybody's eating around 8, 9 o'clock. So,
Yep.
All right.
Yep.
Cool. DaShaun, if people are here in the live chat, what should they do?
Here's the thing. I say that when you come to my house for dinner, if you leave hungry, if we're eating and we're all enjoying the thing, if you leave hungry, that is your fault. When we do this live, we have a chat. And if you got questions, whether it's on our agenda or not, you got questions and you don't ask, that's your fault. So please get your questions in. And my mom and dad are always watching. So if you're joining us, say hello. Let us know where you're joining from, because that's always fun to see.
All right. I think we spent enough time. I'm going to go ahead and bring our wonderful guest to the stage. Please help me welcome Raphael De Lio. Did I get that right?
That's perfect. That's perfect.
Oh,
yeah. A lot of people
man,
say differently. So even my friends, when they were at school, they used to say that differently. So
that's always my worst
Right.
fear. Like, oh
You
man.
say it, introduce yourself, let everybody know who you are, where you're from, what are you up to?
Yes, please.
yeah. Well, my name is Raphael De Lio, as Dan has already said. I've been a Java developer with Spring for the past 7 years, mostly with
Nice.
Kotlin, to be honest, and something that I'd like to keep doing. And recently, a couple of months ago, I think 9 or 8 months ago, I joined Redis as a developer advocate, kind of a change of career here, which was what I was looking forward to doing for the past 2 years. I was kind of building the pave to this place that I got. And here I am today to talk a little bit about Redis, talk a little bit about Spring Boot, answer questions if I know the answer. Ask DaShaun to help me because he also worked for Redis a couple of years ago, and then also with all his expertise. So glad to be here. Such an honor. Thank you.
So you must know our good buddy Brian Samboden then, Mr. Java Champion.
Yes, of course. He's the reason why I became a developer advocate.
That's so cool.
Actually, it's a cool story.
I was just on social media and I saw he's in Hilton. He landed in Hilton Head yesterday. I left Hilton Head yesterday. So I was like, have some fun, enjoy it over there. It's so much fun. So I do love Brian.
Oh, sorry, that's my doorbell. Yeah.
No worries. So I think a really good place to start, and we were kind of chatting about this before we jumped on. I think one of the hardest things about I guess probably any industry, but for me, it's been software engineering. Anytime I go into kind of a new vertical or a new programming language or something new, AI has this problem now. There's a bunch of terms in AI that are really confusing. But like a lot of these terms, like you hear them, and I don't know about you guys, but like when I first started, learning how to write software, like the term like cache or distributed cache or, these terms that come up in programming often make it feel like, oh my gosh, this is a really scary thing. I don't know if I'm going to be able to learn this. And I don't know. For me, like cache was always one of those things because I never really understood it to begin with. So can you kind of talk about what cache is at a high level?
Yes, of course. There's a book called Living by the Algorithm or Living by Algorithm, something like that they make an abstraction of caching really well.
Nice.
Actually, they use the example of a library, right? So basically, you go to a library and you have in the front of the library all those books that are trending right now, and then you have the library itself, and then you have the books that are returned and they are in this card. They're taken back to the back of the library, and then they stay some time in the back of the library until a librarian goes there and sorts them out and take them back to where they should be in the shelves, right? But they say that this is kind of inefficient because you should get these books in front of the library. So they should always be there. So as soon as somebody returns them, you should just leave there because the chances that somebody else is going to want the same book is very high.
Mm-hmm. Yeah.
So this is basically the abstraction that he uses to talk about cache.
I like that.
But caching is about serving things faster, right? And you have levels of caching as well in your computer. So you have the memory that is inside of your CPU, for example, that is very tiny, right? And then you have the memory of your RAM memory, and then you have your disk. But you can even go further. I was thinking about it today. You can go to the cloud, for example. So now we have our data in the cloud, and then I have my data on my phone as well and in my computer, right? So it lives in the cloud, but I can say that my computer is my cache now. If I lose my phone or my computer, I can always go back to the cloud and get my data back, right? If I have like one cloud or something, iCloud or something like that. So caching, in a nutshell, is basically a storage that allows you to access your data faster than it would be to your main database, basically. That's the whole idea. But
and I think a lot of
about...
go ahead.
Sorry.
I think like a lot of like software developers understand like, hey, if I have some data that I want to retrieve later, I put it in a database. I grew up building web applications, everything, build a front end, store some data in a database, retrieve it, display it on a front end. So at what point do you go, okay, well, this is no longer something that I want to store in a database. I may want to store something in a cache, or do you do both?
Yeah, that's where I wanted to get at, right? Because Redis is quite a popular name. I think everybody knows Redis. But the only use case they know about Redis is caching, right? And you see the way you talked about it, that basically you said that you have a database and then you have your cache, that is Redis. But the thing is, Redis was born as a database as well back in 2009. So the creator of Redis, Salvatore Sanfilippo, he wrote in his blog in 2008 that he was kind of frustrated with the way databases handled scalability at the time. So basically you had web servers that could scale horizontally very well, but databases at the time like Postgres or MySQL or other relational databases, they couldn't scale as well, right? And what he wanted was a database that was highly available, that was horizontally scalable, and that was fast. So that was what he was looking forward to doing. And then he came up with Redis in 2009, and Redis turned out to be so fast that it became a really good cache because it's fast. But it's actually a whole database, right? So you have persistence, you have transactions in its way. It's not transactions like in relational databases. It doesn't offer the same guarantees, but it also does, right? But answering your question, you could actually start with Redis as your primary database if you wanted to, because it offers you guarantees of persistence, some guarantees of transactions as well. So depending on the use case, of course, I'm not going to say that it can replace all use cases. It can be a good choice, right? And also going back to 2009 and the late of the 2000s and the beginning of the 2010s, that's when you have the web exploding again, right? And all these companies is starting showing up, like not showing up, but getting bigger, right? Like Amazon, Netflix, Twitter, LinkedIn, all the social networks. And the problem is that they had to scale. They had to serve a lot, like millions of users at the same time. And the databases at the time, they couldn't handle that. So that's when you see a lot of NoSQL databases popping up. Redis is one of them. You have Cassandra, you have MongoDB, and many others, right?
We made it 15 minutes into the show, and this question, I'm sure you're happy to hear all the time. Redis versus Valkey, what's the story?
What's the story? Oh, this is so controversial, right? But basically, I think that what I can say is that by the April of the last year, even before I joined Redis, actually, Redis decided to change the license. So they went from the open source license that they had to a WSPL license, if I'm not mistaken. I'm not an expert on licensing and open source. What I understood from this license is that you could still use Redis for free in most of the use cases, even commercially. There were you just couldn't use Redis just couldn't serve Redis as a service, right? You couldn't sell Redis. That was basically the idea. But for everything else, so 99% of the use cases, it wouldn't be a problem, right? People didn't like it quite much, that much. Some cloud providers also didn't like it. And then they decided to fork it and create their own path. And that's how they went with Valkey. That's what people asked, right? But then this year, we decided to make the shift back to open source. So we're open source again. Redis 8 is out. Redis open source 8. And Valkey, well, it's going its direction. It's I don't know what they're doing, to be honest. And then Redis is continuing its direction with all the use cases and also features that weren't available at Valkey at the time, right? Because they only forked the core of Redis, but Redis has a lot of modules around it that now is part of Redis with Redis Open Source 8 that are not part of Valkey, right? So that's
I'm a big fan. Yes, I did. I worked at Redis for transparency, but I'm a big fan of one of the things that you said is like, yeah, hey, it might not fit all of your database needs, but one of the things that I say a lot is a database is just like a JVM, one size fits most. One thing, whatever you choose, you'll be able to do most of the things. It might not be fully optimized for that specific use case, and there's always a database that gives you a fully optimized for that use case. There's always an option. But with most of whatever is on your menu, you can do a lot of the things that you need to do. And I like Redis because what you get out of the box that's highly optimized for a lot of different use cases, I find in Redis. So I'm a big fan. One of the things that I
Exactly.
do know in the Redis versus Valkey conversation is that the Valkey group made some really big changes under the hood. They changed the way it performs, and it has consequences or outcomes, I'll say. So there are some significant changes, but API wise, things are mostly the same. But with Redis 8, now we get all these modules that were separate as modules. Now we're getting them in core Redis 8. When I download Redis:/latest, I'm getting all the things that are available. And I'm excited about that. I'm just going to say that.
I love that you
Yeah.
brought that up, because we even have like a couple. There's a comment about using Hazelcast, and it always seems like a war, right? Like, oh, this thing's better than this thing, and it's like, for the most part, a lot of these services can do the same things. If you have very specific requirements, you need to look at each of them and compare them. And that's why, like, people get really upset when I say all the time, it depends, but it usually does come down to that. It depends what you're trying to do. If you're trying to do something specific, you need to do your homework. I can't just give you an answer and say, use this one. You got to go through and take a look at like what requirements you have for your project.
So, Raphael, tell me what's cool and new in Redis 8. Can you give me like the TLDR of why should anybody care about Redis 8?
Yeah. So when Redis rose up back in 2000, and that's important you mention these things because most people know Redis as a cache, right? And if you think about it as a cache, as Dan was saying, have a lot of services that do basically caching as well. And well, it's not something widely complex to implement. You can even implement it in memory in your own application, right? Of course, there's a lot of performance and optimizations that have been done throughout the years. But anyway, one of the things that Redis was known as in the beginning was as a data server, a data structure server, basically, because it offered multiple types of data structure. So in the first version, I think it came with lists, sets, strings, and a little bit later it got sorted sets. And then today we have all these data structures. So geospatial indexing, for example, and streams as well. So Redis also works as a string. We got pub sub in Redis. All of that, like more than a decade ago, and most of it written by one guy that was Salvatore Sanfilippo, right? That is like this hacking culture, which is super cool if you think about it. But then in 2017, one of the things that was introduced to Redis was the Redis modules. So basically people started having the ability to extend Redis in the way that they needed. So they could introduce new data structures, they could introduce new commands, do different things, right? So these modules, for example, we had Redis JSON that introduced the JSON data structure to Redis. You had Redis search that introduced full text search to Redis and auto-completion as well. And then you had Redis graph at the time that we don't support officially anymore, if I'm not mistaken. But you start getting all these modules, time series as well, probabilistic data structures, which are super cool, very nice for huge data streams as well, where you don't really need to care about the you don't need 100% accuracy, but you need speed. That's what the probabilistic data structures are for. But basically, all of these modules, they were separate modules. And with Redis 8, they became part of Redis. So now we get all of that with the core of Redis. You don't have to worry about it anymore. And also Redis Insight, it's not part of Redis, but you have Redis Insight, which is the GUI for Redis that allows you to interact with it and, well, see your data and everything else.
So we don't have to worry about the modules anymore. Geospatial has always been a part of the core. I also worked at Garmin,
Yes.
So geospatial use cases are exciting to me, and it's super fast geospatial use cases. You can do your bounding boxes and within radius, all of those cool things. That's exciting. The modules, my favorite module, just because I'm sharing and because I'm excited about it, was the time series module. Now that's a part of Redis 8 as well.
Yes. Yes.
JSON, right? Just like all of the other every database that was out there. We kind of went through these phases, and back in 2017, 2018, actually, no, it came later, didn't it? Was JSON in 2017? But anyways, a
I
lot
think
of the
so.
database
2017,
providers came out
2018.
and they said,
Yes.
oh, we support JSON, right?
Yes.
Just trying to
The
keep
same
up.
thing's
There's the
happening now
use
with
case. That was the
vectors.
feature. And there's where we go. Let's talk about vectors. What do you mean vectors? Vector database. Tell me more.
Before we enter into vectors, I'm just asking, when you were working at Garmin, did you also use probabilistic data structures there, such as the counting sketch? Because I think
Well,
that
no.
for navigation and keeping track, you didn't use that.
Here's the thing. The use case that I always stuck in my head, I got it from Guy, like the way he explained the probabilistic data centers. Like when you have somebody like Dan Vega, who has millions of followers on all the social networks, does he care if it's like 1,100,999, or like could it be off by plus or minus 3? And it's not about like having the right number. It's about being in that right high probability ballpark within like a really small footprint, right? Within I think it's 16K, right? Or you can capture these like all the stars in the known universe. Like, hey, we can capture all these things or all the grains of sand, and we can have this really high probability in this one. One of them is like 16K, and we can kind of get this good ballpark of, hey, we're counting, and yeah, here's the number, right? Because when you're YouTube and you have people that have millions of followers, millions of views, like they don't want to store each view in a table. They want to get a good idea of how many views that has, and they don't want it to explode because there's millions of videos. So to keep the number of watches or number of views on a video for the millions, or maybe it's up to billions of videos now, and keep it within reason, so you don't have to build a data center just to keep track of the number of views.
Right.
That's a great use case for that data
center.
That
there are two use cases, I think, that they're very easy to explain probabilistic data structures, because two very common probabilistic data structures are the Bloom filters, and the other one is the counting sketch. Both of them are given to you out of the box by Redis, right? And the Bloom filter is basically a set that when it tells you that something is not in the set, you can be 100% sure that it's not there. But when it tells you that something is maybe in the set in the Bloom filter, you cannot be 100% sure that it's there. So, but the thing is, the trade-off is that this data structure, it has a fixed memory size. So once it's initialized with, let's say, 1 megabyte, it's going to be 1 megabyte forever, regardless of if you're keeping track of 1,000 members in the set or 1 member in the set. It's always going to be the same size. So if you're dealing with a huge data stream, for example, and for all these probabilistic data structures, it's the same, right? This is very good because of this optimization. Google, for example, uses Bloom filters to keep track of all the pages they have already indexed, right? Because you can think that they have indexed more than, I don't know, 1 trillion pages, more than that. I don't know how many, but imagine having all of the IDs for these pages in
have I indexed this
hash
page?
Tables. Yes, exactly. So
as I'm crawling, right? That's just, I never even considered that. Like, as I'm crawling a site, have I indexed this page before? Ask the Bloom filter, and it's going to come back in less than 2 milliseconds, right? Get that response back to decide, if you want to take action or not. These are great use cases.
Yeah, a hash table is also going to be very fast if you have the ID, right? It's so, but with the Bloom filter, you have the memory optimization. So instead of storing 100 gigabytes, you can store everything in 1 gigabyte, for example. The same amount of data. You see.
I love this. I'm looking at the Redis 8 release notes, and I love this line in here. It says this version offers the full power of Redis, no modules, no fragmentation, just Redis. So I think that's a really cool kind of summary of what Redis 8 looks like. And also some crazy numbers in here. Up to 87% faster command execution, up to 2x higher throughput, up to 18% faster replications.
And understand that we're
getting faster with the new version that is coming.
Wow.
Right, higher throughput than what Redis already had. I talk a lot about the use cases that we deal with. And sometimes 2 milliseconds is too slow, right? And we have customers that are like, hey, 2 milliseconds is too slow. Can we get that down to 1 millisecond so that we can treat our customers the way they need to be treated? And to say that now we're getting these massive performance improvements that remind me of what we're getting out of the JVM, to be honest, right? When I look at customers that are using Java 8 and I do a side-by-side with what's available already in Java 24 or the early access release of Java 25, and that we have things like virtual threads, like there are massive improvements in the performance. And I just in my head, these are things that I think about. I put Redis into that same kind of bucket. Like we're getting these massive improvements
Yes.
out of the box, and all we've got to do to take advantage of them is upgrade our Redis.
Yes.
Am I on the
It's
right path?
crazy. We have these conversations with customers all the time, and it's just like everybody, like from a developer standpoint, they're just like, oh, what are the new features? I don't really need that. I don't need to upgrade. Like, just upgrade, like staying on top of upgrades for the major pieces of software that you use can be such an improvement. And not only that, save you a ton of money because of all these things. So
security wise, right? As well.
Yeah, security is another huge one. Yeah. From the JDK to Spring to Redis, right? Like stay up to date for security, performance, new features. Like it's a big thing to make sure you are committed to doing.
Yeah. One of the things I've been saying
but
is like we're all developer advocates. I try to advocate for the things that the developers are going to get credit for. And the security stuff is great. Like, yes, I don't want you to be on the wrong page or on the front page for the wrong reason. But if you patch something and you fix a security hole, your CISO, your security team's getting credit for that. But you get an 87% performance improvement or even a 2% performance improvement just by upgrading something, the developers are going to get the credit for that. So that's what I advocate for, is the developers getting those benefits, because nobody else can take credit for those kind of things. So that's where I'm at. But
and
we talked about some of the data types. Go ahead.
Yes. No, sorry. I was just going to say that it's so interesting, this thing that is perception, right? Because you were saying that 1 millisecond and 2 milliseconds and how fast we can perceive something to be. I was reading this book that is the Victorian Age Internet, that they basically talk about the telegraph, right? And one of the things that they say is that when the telegraph came out, people said that it was too fast for the truth. So you can imagine the telegraph would be a joke, right? Compared to the internet, but still we can perceive the internet as slow sometimes, right? And if you think about it, if you travel with the speed of light from Sydney to London, it would take you 5 milliseconds to get there. So it's virtually impossible to go faster than that. Even if you can send data in the speed of light, it's going to take 5 milliseconds to travel this distance, right? And then, of course, you have a lot of things you can do, replication, multi-zone, all these things, right? But speed matters. And that's what Redis also gives to all the people, right? And the thing is, people are using Redis as a cache because of that. And most of the applications, they already have Redis as part of their stack. And then Redis also offers all these use cases because it's such a Swiss knife that people are not taking advantage of because they don't know that these features are there, right? Like the probabilistic data structures, the time scale, the time series, the streams as well. You can use that as a message queue. Has been used as a message queue since the beginning as well. So all these things people are not taking advantage of.
Do you find that a lot of people come to Redis just for the cache and then realize that there are other things they could take advantage of?
No, not really. You see, because if you, I think some people do, of course, and some people start using Redis for other reasons than caching. But a lot of people have used Redis just as a black box, right? Because one of the things with Redis is that once you start it up, you forget about it because basically it doesn't crash. That's it's a very reliable piece of software. It's very well implemented as well and elegantly implemented. So checking the code base is nice for learning data structures, especially. But and when you use it, for example, with Spring Boot, you can just add an annotation there, add cacheable, or add a new
So let's talk about
dependency
that.
sessions and
we have at cacheable. So Redis is one of the default implementations for our at cacheable annotation that allows you to basically cache anything by slapping this annotation on it. And the other one is session store. As a session store, your at session, we have an implementation that's just for Redis that allows you to allow Redis to keep track of like a shared session store across your cloud native microservice deployment, or even your monolithic or monolithic deployments. Having someplace that's fast to store your session information comes easily out of the box with Redis in Spring.
So I think a good question there is then if I wanted to get started with Redis and Spring and I go over to start.spring.io, if I type Redis, I have a few options. Like what if I just wanted to add some cache, what am I doing there?
Okay, if you just want to add some cache, I think that you have I don't know if you should go with Spring Data Redis just as the starter, or if you have like some Redis cache
I'm gonna go look.
dependency.
There is a Spring
Yeah.
Data Redis access and driver.
Yeah.
So
I think all that
Because you
you need
have
is
Spring
the
Data
Spring.
Redis for the JPA, right? And then you
You
have
do, but I think
Spring
all you need
Session
is
for
Spring
Redis as
Cache
well, something like
abstraction.
that.
Spring Cache
Yeah.
abstraction is a dependency, and
Yeah.
any one of the Redis drivers, I believe, will work. Any one of those
Right.
Yeah.
options, we can have the reactive or just the driver, and you're off to the
Yeah.
races. And there are some differences under the covers between those different solutions. But to get started with caching, I believe that's all you need. Grab that Spring Cache abstraction and grab any one of the other
So the cache abstraction
Redis,
then looks for whatever's on the class path and then uses that.
just like Spring does, right? Just like
Perfect.
Spring
May
does.
I
Yep.
may I advocate for a library that is developed by Redis itself for Spring,
Absolutely.
developed by Branson Button actually, which is the Redis on Spring, so object mapping Spring. So basically, you have Spring Data Redis, right? And Spring Data Redis works well with the core of Redis. So without all these modules, but as we've been discussing throughout this podcast, Redis has evolved in the past 15 years to become much more than just a cache. And well, Spring Data Redis, they didn't implement the features that came from the modules itself, right? So we developed Redis on Spring, so you can get it for its open source as well. You can just add as a dependency to your project. It's built on top of Spring Data Redis, and it adds more capabilities. So it gives you access to all of this probabilistic structures we were talking about. It gives you the Redis query engine as well. So you have the full text search auto completion, which is super fast as well. You can query your data from Redis. You can create schemas, indices, all of that using the abstraction that you're already familiar with from Spring Data, basically. So all these
Well, I'm
annotations
going to say that that Redis on Spring, it was it came out of necessity, right? We needed to be able to access these modules. I'm going to go a step further. The modules, the way that the modules were licensed when Spring Data Redis was being developed, that they weren't allowed to do it. But now this is another thing, and I've been thinking about this a lot the last couple of weeks. Is with Redis 8, now we can access all those new data types. There's a data type that also does not exist in Redis OM. That's the time series data type is not in there. And in order to get access to it, I think it's just in the Jedis driver where you have access to creating a time series and be able to use time series just like you do in other places. But I think in my head, we are at this opportunity with Redis 8 and the way things are being packaged and delivered now. We have an opportunity where maybe we can, and I'm talking to you, community, maybe we can start to pull in some of the other data types that don't exist in Redis data. We might be able to bring those back in to Spring Data Redis. I would love to see that. And I went down that path the last couple of weeks is trying to find, specifically it was around the time series data. Get time series, what would it take to bring that in? And I went and looked at Redis Home to see if it had it, and it didn't have it in there as well. But there's a lot of opportunity right now, and this is a great space to be in because you had already mentioned most teams, most organizations, Redis is already on the menu. Like there's no, I don't have to pull it in. And we've done different difficult things with other database types before. Other databases, I've turned them into a stream or a queue when it wasn't efficient, right? And it's not just mixing use cases inside of a database. When I mix use cases inside of my SQL database, I also have to think about the way that I choose my the file storage, right? I have to make sure I choose that implementation, and I've got two competing types on the same database. That becomes tricky. I don't run into that with Redis, right? It's in memory, so I can have multiple use cases in the same database instance, and they're not noisy neighbors, right? That's one of the nice things. So we have this great thing that's already on the menu, and there's a lot of other use cases that we can lean into.
Just in addition, it's see memory first, right? It doesn't mean that it doesn't go to
memory
the disk.
first.
Just see memory first.
Good point. But we were talking about data types. We talked about JSON, and now the new thing is vectors. So we had like a vector DB implementation, but now we also have this vector type inside of Redis. What does that mean? What's the difference?
Okay, so so let's talk about the Redis query engine first. Right? So I was saying that the Redis query engine can be used for doing full text search and for doing auto completions and indexing and efficiently storing and retrieving all the data from Redis in the speed that you're used to with Redis, right? So it's fast. And back in 2023, if I'm not mistaken, even before ChatGPT came out, we decided to implement vector search in the Redis query engine as well. That was known at the time as Redis search. So it was rebranded to the Redis query engine more recently. And with Redis 8, we got even faster indexing. So today, if I'm not mistaken, according to some benchmarks that we ran, that may not be the you get it, right? It's the fastest vector database out there compared to the most popular competitors out there. But it's also the most scalable one, so it can scale to 1 billion vectors, and while keeping a median latency of, if I'm not mistaken, 200 milliseconds, if you keep an accuracy of 9% using a hierarchical navigable small world index, or if you keep an accuracy, no, it's the opposite. If you keep an accuracy of 95%, you can get a median latency of 200 milliseconds. If you get an accuracy of 90%, you can get a median latency of 1.2 seconds, which is super fast for vector search. So basically, this is the first way of doing vector search with Redis, which is through the Redis query engine, the most mature one. And now we got this new data type. So Redis is all about data types, data structures, right? So you got this new one that is vector sets that allows you to also store vectors in Redis and search them efficiently, but in a more, let's say, straightforward and easy way. But it's not as mature as the Redis query engine yet, and it doesn't give you as much flexibility, especially in terms of like choosing the indexing that you'd like to work with, for example, or all these things that have been matured throughout the years with the Redis query engine already.
On this topic of vector databases, there's another really interesting use case that I've seen you and others talk about. It's this idea that, and this is where I think we bring it back to AI a little bit. This idea that, hey, I'm making queries or I've made something available and those tokens become expensive. One of the use cases that I find very interesting and I can totally see the value is this AI semantic caching. So that when I'm making queries, I'm asking the GPT information. If it says, hey, you've already asked that question, or somebody already asked that question, and we've got that response here in our cache. Tell me more about that. How did that come about? Give me something interesting.
Yeah. So what I'm seeing that is happening with agents and agentic applications is that people are throwing everything in LLMs right now. All right. So it's happening a little bit like it happened with the cloud. So people start like exploring the cloud and sometimes overusing it and getting expensive bills by the end of the day. Right. And the same thing is happening with LLMs today. And not everything needs to go through an LLM. So we have use cases, for example, as you said, semantic caching, but not only that, we have semantic classification and semantic routing that can be done with vector databases and vector search, vector similarity search as well. So when you're talking about semantic caching, and you can start with that use case, basically what you're doing is you have, for example, this grocery store here in the Netherlands that they allow you to search by a term, for example, search for birthday party. Right. And then it's going to show you the items that are related to birthday parties. So I don't know, balloons and cakes and things like that. But the way it does it is by going to the LLM and saying, hey, this person is asking for birthday parties. Give me all the items that are related to this. And then the LLM is going to compute that and give back the answer to the application. And then the application is going to use
candles,
that to search.
Gift wrapping. Okay.
Exactly. And it takes time, it takes money, it takes earth resources, right, as well. So it takes, I don't know, at least a second for the LLM to compute that and give it back to the user. But if I'm doing groceries, I don't want to wait for a second every time I search for something, right?
Who's got time for that?
Exactly. So what this grocery store does is basically they go to Redis and they store the prompt, but not the string representation of the prompt. Instead, they store the vector representation of so that they can perform vector similarity search afterwards. So if somebody asks a similar question, they can go to the database first, to Redis, do similarity search there. If something is similar enough, it means that something has already been answered so that they can get the response from the database instead of going to the LLM. If nothing is similar enough, then they can go to the LLM and get the result from there. So this is the
That's pretty
first
cool.
use case, you see, and this can lower your costs by 60% depending on the use case, or even more, or even less. Yeah.
And is that what some of these large language models are doing? Is that pretty much what they're doing? Like OpenAI, Anthropic, Claude, Google Gemini, some of them provide this semantic caching. Is that kind of how they handle it then?
What do you
there's
mean by
at
they
least
provide the semantic caching? Sorry.
in their implementation, where we get the chat interface that we get with ChatGPT, we get
Even
an
on the
interface
API
that's,
side,
I
this
think,
works. So
yeah, I know there's at least one implementation out there that is using this AI semantic caching with Redis.
nice, cool.
All right, I know that OpenAI, if I'm not mistaken, is using Redis very extensively, especially for ChatGPT. I'm not sure for semantic caching, because this is one of the use cases, right? Another very nice use case for Redis is actually memory. So you have like short and long-term memory.
Oh yeah.
And you have two types of long-term memory, and you also need speed, right? You don't want to choose to wait like 200 milliseconds to get the memory from your vector database. You want it to be fast. And then Redis works really well for storing the memory for your applications. And I can go through the two types of memory if you think the audience would like to.
Yeah.
I want to make
That's
sure,
definitely interesting.
didn't you and I both go down the path of using Redis as our memory advisor in Spring? Didn't we do that at the same time?
Me?
Anyways,
No,
that's what I do. I was talking to Raphael.
Oh, sorry.
To me? Okay, sorry.
Yeah, we can use Redis as our advisor when we're using Spring AI. We can use Redis to keep track of our memory, our conversation memory, our RAG memory. We can do that.
Right. So there's
really
there's an interface for that. There's two kind of implementations already, which is an in-memory, and then there's a JDBC one. But yeah, you could certainly just kind of implement that interface and write your own abstraction for that.
Yeah, I think that there is not an official one for Redis yet for the chat memory. Right. But for Spring AI, I don't know actually, and you guys could tell me if you have the two types of memory, the short-term and also the long-term memory, or if you have only the short-term memory.
No, it's really just
right. I can keep track of my conversation history. I can store that in my JDBC. I can store that.
Yeah, but if you start a new conversation, for example, do you keep track of?
No. So like basically you have a number of messages that you can hold, and you can configure that. I want to hold 10 messages. I want to hold 1,000. You probably can't hold 1,000. You can't fit that into the context window. But yeah, it's really just about that. But then as DaShaun said, you can assign like an ID to that memory and then store that somewhere and say, if we need to recall that later, we can go ahead and pull that.
All right. So yeah, exactly. You have these three types of memory actually. So you have the short-term memory, and this is like the chat history. Basically, as I said, you keep track of 10 messages, or you keep track of 1,000. And when you run out of this threshold, you can even ask LLM to summarize everything exactly and keep track of and try to keep track of all the context. But the other type is a long-term memory, right? So if you use ChatGPT today, for example, and you started with chat, you're going to see that it remembers things from you, which it didn't do in the past, right? But now it does. And Redis is also a nice use case for that, basically, or a nice database for that because of its speed, especially with vector similarity search. Because the way you want to implement it is basically the user sends a new query, right? And then you want to check throughout the long-term memory if something related is there. And the way you do it is with semantic search that is powered by vector similarity search. So you basically have to turn the query from the user into a vector representation of that, and then compare it to all the memories in the database and see, okay, which are the ones that are related to it, and return that to the LLM so that the LLM can use that to generate an answer for you.
That's really cool. And it freaked me out the first time I saw that kind of the long-term memory. So like if you go into like ChatGPT now, I can just say, hey, write a bubble sort. And if you look under the thinking, it kind of tells you what it's thinking about. And it goes, oh, Dan's a Java programmer. I'm like, what? How did you know that? And I forgot about that kind of long-term memory. So it just wrote a bubble sort algorithm in Java because it knew I was a Java programmer. So pretty cool.
Yeah.
And call back to our session with our last episode with Mark Pollitt. That whole idea that Raphael brought up is like, hey, I can have this short-term memory, and as I reach that message depth, I can summarize that memory, and then hey, this is my rebase. So I can kind of keep as as much of the context as possible as what's relevant by summarizing. And then, later in the conversation, I can just kind of re-summarize, hey, here's where we're at.
Yep.
We're trying to, I think it's on the roadmap. I think it might be even being worked on already for Spring AIs to make that a part of the implementation details.
Yeah, that'd be
Taking care
cool.
for you.
If you've used a tool like Claude Code, which is kind of a terminal-based agentic IDE type of thing,
Yeah.
if you go in there, you could say clear, which basically flushes the entire context window. But you can also say compact. So it takes everything and kind of summarizes it and goes, okay, now I can use that and build upon that instead of having to keep all of that conversation in that in that memory, right?
And that's huge.
Yeah.
That's massive.
Yeah.
That's where I saw it first, was in Cloud Code,
Yeah.
and just that makes absolute sense. So thank you for that team and that idea.
So we already talked about two use cases, right? So the first one is semantic caching. The second one is memory. So it can be short or long-term memory. In long-term memory, you have two types of memory. You have episodic. Is that the right way of pronouncing this?
Sure.
Word? Episodic.
Yep.
Yeah, and also semantic memory. So episodic memory are those that are personal and relatable by the user. So something like their name or some place that they've been, or like some date or something like that. And the semantic are actually factual things. So you start asking about Paris, for example, and it's going to say Paris is a romantic city. This is a semantic fact, for example, or maybe not a fact, but you got the idea, right? So you have these two types of long-term memory. And going back to semantic caching, what we're going to be releasing, we're just like in the phase of testing and everything else, is LangCache now. So you have LangChain, you have LangGraph, and now we're going to have LangCache, which is basically Redis as a semantic cache, as a managed service, as a semantic cache for you to use out of the box through the cloud.
That's awesome.
Well. So it's just about to get out. And then we just talked about these two use cases. There are other two. One is semantic routing, and the other one is semantic classification. Semantic routing is a...
These are new words to me.
Okay.
Help me out. What is semantic routing?
Okay, so semantic routing is a pretty cool one, because what we're doing today, for example, with LangChain or Spring AI, you have the tools, right? You do the tools. And what Spring AI is going to do under the hood, if I'm not mistaken, is going to call the LLM and say, hey, we have this tools that you can use. Choose one, pick one to use, right? Something like that. But then you take the time to go to the LLM. The LLM takes the time to process it, and then you have to come back and then do another call to the LLM once you get the information back from this tool. So what you can do instead is actually, you can have like this 2, 3, 4, 5 tools, whatever, and then you create references for this tool. So what would people say to call this tool, right? And you can even synthetically generate them. So you can go to ChatGPT and for example, one talk that I did was for Blue Sky, and I wanted to understand what people that were interacting with my bot wanted my bot to do. So if they wanted to summarize the things that were happening about artificial intelligence, for example, they were going to ask something like that. Hey, please summarize something about this topic, right? So you can create 100, 200, 300 references for that tool. You store them in your vector database. And then when somebody asks you something new, you compare their text, the vector representation of the text, with the vector representation of these references in the database. And if they're similar enough, then it means that they are asking this tool to be called. So you don't have to go to the LLM, and you can do that in 5 milliseconds.
So I no longer need to make that first call to the LLM for it to figure out which tool to call. We can already figure that out now and just send the context along. So we've kind of shortened, there's latency there making these calls back and forth, right? So we've kind of shortened that, which that'd be really nice. That's cool.
Yeah, thank you for connecting the dots on that, Dan. That definitely opens up my mind to, we're doing these agentic workflows, these, agentic, the more tools that we have made available to the LLM, the more work that has to be done. But there's definitely a cool demo here where we do that semantic routing.
Yeah, and here's the problem. One of the problems with tools is you don't want to give an LLM a bunch of tools. You can give it 5, you can give it 10, but when you start giving it 50 or 100 tools, it gets very confused on like which tool it should choose. I wonder if like we use this use case, if we're doing that locally and we have enough examples of like when this prompt is given, this is the tool that needs to be called. I wonder if we can get better results out of that, because you can't overload an LLM with a bunch of tools or things start to really break down at that point.
Yes, I don't really have an answer for that.
Yeah, no, I know.
Yeah. But what I can say is that we've also developed a optimizer, because the thing is, what's the threshold that you want to use for
Yep.
the similarity, right? So how similar should this be to the references?
Yep.
So to make that tool to be called. And we have an optimizer that you feed with some examples, and then you can also feed with different embedding models, right? Because
Yep.
one of the questions many people have is, oh, which embedding model should I be using? And then this optimizer is going to tell you, oh, it's going to run the semantic routing on that, and then it's going to say, hey, this is the threshold that is most optimal for the kind of data that you have. But now, if it's going to work well with 100, I don't know, honestly.
Yeah. No, I mean, you probably don't want to. You're probably not creating applications that need 100 tools. Is kind of my point. But if you want to start throwing more tools at it, it's something you got to think about. So.
And it's also good for like creating guardrails, right? So if somebody starts talking about something that you don't want your application to deal with, you don't even have to go to the LLM. You can just hit there. Oh, it's similar enough to that. So stop them right there. Sends like a generic message.
Oh, nice. Yeah, we had one of the popular LLMs in the news last week for responding to things that it shouldn't have been responding. So yeah, that hey, maybe they should.
Now imagine that you're using this. They're using this LLM in production to talk to your customers.
Baraka's got a question. He says, "What's the weirdest use case of Redis you've ever seen in production?" And I'm going to change it, not from weirdest. I'm going to say most interesting. What's the most interesting use of Redis you've seen in production?
Maybe that's something that's not as common.
I know mine.
Yeah, I don't know, because now that I've seen so much, I don't know what's uncommon.
Nothing's
if you
weird.
had asked me that question before, yeah, exactly. But for example, we have this customer, they're storing 40 terabytes of vectors in Redis. Terabytes. So when you think about it, like, oh, we have all this memory,
good answer.
Like all this RAM.
Good answer. Yeah.
And you can so because sometimes you have people, oh, like you don't have enough memory. No, maybe you don't have enough money, but if you need the latency.
Last week conversations, I like to talk about milliseconds matter, and last week I said this milliseconds matter, and they quickly spoke up, but they said microseconds matter. Like, for what we're doing at financial institution, it's not we're not measuring in milliseconds, we're measuring in microseconds. So
exactly.
And that's kind of like, I might have to change my conversation a little bit, but these things matter. And why you'd put 40 terabytes of vector data inside of Redis, because it matters. The speed matters. And if you're trying to compete, right, things are not going to get slower. Right?
Yeah.
These use cases are only going to become more important, and the speed at which you access this data or get routed to the right tool, that matters, and it's going to matter even more going forward.
Yeah. And there are other use cases. Oh, sorry.
No. Go ahead.
We have one now that just came to my mind, that is recommendation systems, right? That is powered by vector databases as well. So basically, have Netflix or YouTube, and they have to recommend something new to you, and they have to do that based on what you've watched, right? So how can they do that? So they can basically create, let's say, lists of, okay, this movie is very similar to this other one, but that's not scalable. Right. So what they can do is actually look at the synopsis and vectorize all of them. And then, okay, they like this movie, so let's find synopses that are similar to this one in our vector database with vector similarity search. Or even e-commerce, for example. So you have, I don't know, let's say Amazon or Bol here in the Netherlands. They can show you something that is related to the product you're buying, and they can do that with vector databases as well. Basically building recommendation systems from there. That need to be really fast, right? So you don't want to wait. If you're there in your shopping cart in the e-commerce, they need to show you very fast so that you can add that and support the capitalist world that we are all inside.
Nice. I just wanted to point out, because when I hear these conversations, one of the things I like to do is go off and tinker. And when I go off and tinker and I can't do something and I have to like install 10 things, like it's always frustrating. So I just want to point out, if you go over to start.spring.io and you pick something like the Redis driver or the query vector store, and you put Docker Compose on there, it will create the appropriate service for you. You can download this and run this right away. Makes it really easy. It's one of my favorite features because it makes like doing these types of like quick MVPs or just kind of playing around with something really easy to do. So if you want to give it a spin, start that Spring.io, pick the Docker Compose port. And then if you're using the vector database or just the cache or the database, the Redis database, it'll spin that up for you. So
and you can go.
Oh, that's
You can
great. I
start
didn't
it.
know that. Wow.
And we'll encourage
So-
everybody that's watching or listening, we'll encourage you to tinker. You've got some
So-
stuff, you've heard some cool use cases. Go tinker.
So if you select the Redis driver and the Docker Compose dependency, it's going to create a Docker Compose file for you with the Redis
Yes.
with the
image inside.
service. Yes.
Ooh, that's
And it
great. I
uses
didn't
the
know
latest.
that.
Look at
Yep.
that.
Yeah,
great.
and you can use it
Nice.
uses the latest, but if you want to pick a specific one, you can do that. I always tell people to go ahead and it just adds like a single port on there. Go ahead and add the 2 ports so one maps to your machine, so you can go ahead and connect to it. But yeah, it makes things so much easier.
Nice.
DaShaun and I go around. We hate like that README file where you got to download the project and then go through and like configure all the services that you need.
Yeah. 10 steps before you can hello world. That's no fun.
We are living that git clone run lifestyle.
That's exactly right. Git clone run. Right. And if you've got that Docker Compose in there, then you're all set.
Yep. Cool.
Yeah.
All right.
Yeah, time
anything-
flies when
There is
you're
a-
having fun.
Look at
If
that.
I have time for another use case with vector
Yeah,
databases.
go for
it. So basically you have semantic classification too. And what you want to do is classify text. So let's go back to the Blue Sky bot that I created, for example, and I connected to Blue Sky's WebSocket and I'm listening to everything that's happening in real time, right? All the messages coming through. And I want to find out if those messages are about something, some certain topic. Let's say all this I want to pick the messages that are about artificial intelligence, right? One way of doing that is by going to the LLM and asking, hey, is this text about artificial intelligence? And it's going to tell you. But it's going to take time. It's going to cost money, right? It's going to consume Earth resources. Not ideal. Then you have another way that most people are not exploring that is basically using a tiny classification model called zero-shot classification model, right? So you can run that locally. And I don't know if you know that, if most people actually know that, that they are watching, but behind Spring AI, we have DJL, which is the deep Java library. And the deep Java library is the way Spring AI uses to spin up the embedding models from Hugging Face, so from transformers, and you can choose different ones as well. But the DJL also allows you to use zero-shot classification models. So you can go there and say, I want to use this model, and then you send the text to it, you send the premises, and it's going to test the text against the premises and see, okay, is this about artificial intelligence? 100%. Okay, I can go on with that. But it's going to take a few 100 milliseconds to do so. Another way of doing that is going back to semantic routing, using the same strategy, but now for classifying text. So you ask ChatGPT, for example, to generate 100 tweets or posts from Blue Sky that are about artificial intelligence. And then you vectorize this post. And if something's similar enough, you know that they're about a certain topic. You see, so this is another use case for vector databases, because I think it's important to mention these use cases because most people, they just think about RAG, right? Vector databases.
I was just going to say that.
Have like all this world. Yeah.
Yes. I was just going to say that. I knew that my knowledge of vector databases were pretty limited to RAG because that's what I've been using it for. And I'm hearing all these different use cases. And I've heard this before, that you can do a lot more creative things and really cool things with vector databases. So I got to put this on the list of things to learn.
Raphael, thank you so much.
Thank you.
Thank you so much for joining. Time does fly. I can't believe that was already an hour. This is good stuff. To everybody that's watching, go check it out.
I was going to say, go ahead.
Sorry. No, I was going to ask if I could advocate for a few things.
Yes, I was going to say, yes, please leave us with some closing remarks, where we can find you, that kind of thing.
Cool. I was kind of afraid in the beginning because you asked me to start with caching, and to be honest, caching is not my expertise lies. And for the past 8 months, I've been researching AI and especially vector databases, and have a YouTube channel, the Redis channel, where not only me but also my colleagues, we've been creating videos about AI, but also about the concept. Cool. So what is an embedding model? What are the differences between exact and approximate nearest neighbors? What kind of algorithms you have there? What is visual search? What is semantic search? All of these concepts, we're talking about them in a very short and concise way to be mindful of the time of people as well. And you can basically follow the channel.
I'm your audience. I'm going to subscribe to that one. So and I'll make sure all this gets into the show notes. So
Thank you. Nice. And also, we have Redis on Spring. So if you're a Spring developer and you want to try out Redis on Spring, you have these two annotations that are pretty cool. So basically, you have the your entity model or entity class, and you can annotate the fields with add vectorize and add index. And these are going to create the vector for you automatically using Spring AI under the hood. So we're using Spring AI. All right.
Wow.
And you can choose the provider, you can use the OpenAI, and this is just going to spin up the embedding model for you under the hood. So you don't have to worry about that. All this magic of annotations. And
Love
you also
that.
have the
Yes.
index annotation that's going to create a schema inside of Redis. And then you can choose if you want to use an index of flat type or hierarchical navigable small world type, or and the number of dimensions that your embedding model is using, everything.
Wow.
It's super easy to get it started with. I'm getting a GitHub repository with a lot of recipes for Spring Boot with
Perfect.
Redis. Yes. Maybe we can share that as well.
Yeah,
You know,
absolutely.
so-
If you can,
Yeah.
if you could send that over, we will put all of that in the show notes. And like I said, the less friction I have to get started with something, the more likely I am to like tinker with it a little bit more. So this is awesome to hear.
Yeah, and it's all the Spring builder of annotations and Spring AI under the hood, and Spring Data Redis under the hood as well. We have some a few optimizations as well. So
Awesome.
It's certainly something to try with.
Raphael, where can folks find you if you want to be found on the internet? Not everybody wants to be found, so but
No,
in the position of a developer advocate, I'm guessing you want to be found.
Exactly. Also, if I haven't answered any questions, if I didn't know the answer for some of the questions, or if you guys wanted to ask more questions, DaShaun says if people don't want to live hungry, right? They can connect with me on LinkedIn, Blue Sky, GitHub. You can send me an email, raphael.delio@redis.com.
Perfect.
Feel free to reach me out anywhere. My job now is to talk to developers, help them. We have a Discord channel. On the 23rd of July, we're going to have a hackathon going on through dev.to. So you guys can tune in dev.to/challenges. July 23rd, we're going to have a hackathon going on. So people are going to be talking about Redis. They're going to be connecting to our Discord channel as well, using Spring Boot, I hope, because I love Spring Boot. I have the Spring ecosystem, especially with Kotlin. I'm not sure if most people are going to love to hear that. I even have Cody here. I don't know if you guys saw that.
Oh, nice. I have no problem with Kotlin at all. I just don't use it as much. So
yeah, I love it. Once you get it started, you cannot stop.
That's what I keep hearing. That's what I keep hearing.
Yeah, it's so nice.
Thank you so much.
Cool.
Such a pleasure.
Thanks for joining us. This was awesome. And we'll have to probably do a follow-up when I have some time to dig into some of this vector stuff. We can dive deeper on that. So that'll be fun.
Nice. Cool. Thank you so much for having me here. Such an honor.
No problem. Thanks.
Thank you.
Thanks,
Thank you.
Raphael.
Take care, everybody.
Thanks, everybody, for joining. We'll see you next week.